Number 1 says list the intercepts of y equals x squared minus 4x minus 12. Cell phones need to be put away now, please. I do not want to see them. Okay. The easiest one is to find the y-intercept. Tyler, what will be your y-intercept on that one? Negative 12. So you put y-intercept is negative 12. Now, I got a question for you. Let's say this is a multiple choice test. This is a multiple choice test, and they do not have the answer negative 12. They have it in ordered pairs. Negative 12, 0, or 0, negative 12. Which one would you choose? 0, negative 12. Very good. Now, let's figure out how to find the x-intercepts. When you're finding the x-intercepts, you substitute 0 in for what variable? Y. Very good. So let's do that. Number 1. 0 equals x squared minus 4x minus 12. What type of equation is that now, Jaden? What type of equation is that now? Quadratic. Very good. What's our first line of defense for solving a quadratic, Parker? Factor. Very good. I'm going to factor that. That's be x minus 6 and x plus 2. So my intercepts are 6 and negative 2. And x-intercepts mean that's where it crosses the what axis? Class? Which one? Say it one more. What is it? Thank you. Number 2, it says determine the axis of symmetry for y equals 3x squared minus 5. Let's remember that formula. Can anybody remember? X equals negative b over. Very good, guys. You just made my Monday morning. All right. What is your b in this? Is there b? So it would be 0 over 2 times 3. So it's x equals 0 is my axis of symmetry. That means there's a vertical line going through x equals 0, and if you folded that parabola, it will fold on top of each other.
What would B stand for?
B, okay, your a is the value in front of x squared. Your b is the value in front of x. That's why I don't have an x. That's 0. And c is your constant. All right. Let's look at number 3. It says list the intercepts of the graph and determine the symmetry. All right, let's go with the y-intercept first. Miss Huner, what's your y-intercept in that particular problem? 0. Very good. Mr. Hussey, what would be my x-intercepts in that problem? Negative 1, 1, and one more. What is it? 0. Very good. All right, now it says determine the symmetry. Okay, determine the symmetry. Now, talking about x symmetry, symmetry with respect to x-axis, y-axis, and origin. Remember how you could check for that. Let's say now, I'm making a point up right now. Let's say I had point 2, 3. If it has symmetry about the x-axis, which coordinate would have a different sign? The y. Very good. It's the opposite. So if it had symmetry about the x-axis, I would have 2, 3, and 2, negative 3. Does that make sense? If I have symmetry about the y-axis, which one changes? X. I would have 2, 3, and then negative 2, 3. What if I have symmetry about the origin? What happens to them? They both change. So you have 2, 3, and negative 2, 3. Negative 2 and negative 3. Does that make sense? You remember that from first 9 weeks? Okay. So guys, this is a hard picture, and I'm going to show you a better picture in a minute. But I located a point here, negative 0.5 and 2.3. And then over here it was 0.5 and negative 2.3. What do you notice about those points? I got negative 0.5, 2.3, 0.5, comma negative 2.3. They both change. So this has symmetry about the what? Origin. That's what you would put, okay? Now, I do not like that picture, so I got a better picture here. I went back to our first 9 weeks notes right here. For example, this is symmetry about the origin. Do you see how the x and the y both changed? That's symmetry about the origin. Here, negative 4, 2, 4, 2. Your x's are opposite. That's symmetry about the y. Does that make sense? Okay, that's our review. All right, let's look at number 4. What type of equation is number 4, Nick? Very good. Harrison, how does he know that's a quadratic? Highest degree is 2. Very good. What's our first line of defense here? Fung, what's our first line of defense? Factor. Very good. Alright, so let's do that. 14x squared minus 15x minus 9 equals 0. This is bust them up because the coefficient is greater than 1. I'm going to multiply this. 14 times 9 is negative 126. It's got to multiply to give me negative 126, add to give me negative 15. This is a hard one. You have to think about this one. You use your calculator. It's going to be negative 21 and 6. So you got 14x squared minus 21x plus 6x minus 9 equals 0. I can take a 7x out of that first one. I take a 3 out of the second parentheses. And I get 7x plus 3 and 2x minus 3. So x equals negative 3/7 and x equals 3/2. This is review of first 9 weeks for our final exam. Are there any questions on number 4? Number 5. Mr. Nolan, what type of equation is that? Very good. That's also quadratic. What do we need to do first, Mr. Wilson? Move the negative 2 over and get it in standard form. Standard form means it's set equal to what, Kinsley? 0. Very good. So I'm going to move the negative 2 over. Alright, I'm going to try to factor it. It's got to multiply to give you 8, add to give you 12. Are there two numbers that can do that? No. What's our second line of defense on a quadratic equation? Quadratic formula. Here we go. Opposite of b is negative 12 plus or minus 12 squared minus 4 times 2 all over 2 times 4. When you break that radical down, you get 4 square root of 7. Can I take a number out of these three values here? What can I take out? Very good, 4. And you're left with that. Negative 3 plus or minus square root of 7 over 2. What is the significance of that answer? That is where it crosses the x-axis. Very good, Madison. That's where it crosses the x-axis. Those are the roots. What's another name for roots? Zeros. Very good. Are there any questions on our workshop today? Okay, we did 1 through 5 on our final exam. Remember, we've done the back page of our final exam already. We've completed all that. We did 1 through 5. My goal tomorrow is to do 6 through 8. We're going to have this finished by Friday, doing like 3 or 4 a day, and then we're going to keep reviewing for our final exam next week. All right. Now, guys, on Friday, let's look up here to our learning targets. On Friday, we start our final unit for this semester, Unit 8. It's on right triangle, trig, and oblique triangles. Remind me what the word oblique triangles mean. They're not right triangles. Very good. That's what we're going to look at today. But let's look at our 2 learning targets that we did on Friday. The first one, I can determine the missing sides and angles of a right triangle. Okay, we reviewed our trig ratios. Let's go through them. What is the definition of sine in respect to the right triangle? Very good. Cosine. Everyone. Tangent. Thank you. Cosecant. Hypotenuse over opposite, because it's the reciprocal of which one? Sine. Please have your cell phones put away. Okay, which one is the reciprocal of secant? Hypotenuse over adjacent. What is the okay? Which one? Oh, which one is the reciprocal of secant? Cosine or sine? Very good. All right. What's the reciprocal of tangent? Okay. First off, what's the name of the trig ratio? What's the reciprocal of tangent? Okay. What's the definition of cotangent? Adjacent over opposite. Very good. So for this one, let's look at this problem right here. I drew a little example here. We want to find this angle. What is the relationship here? Opposite. And that's the what? Hypotenuse. Very good. So I'm trying to find the angle. Would I hit sine or second sine on my calculator? Second sine. Very good. Here, what's the relationship here? Adjacent. What is that? Hypotenuse. I would do what here? Cross what? And then I would get x times cosine of 25. And then I divide both sides by what? Very good. How do we feel on that learning target? I need a signal. Good job. What does it mean, guys, when I say solve a right triangle? Juliana, what does it mean, Juliana, when I mean solve a right triangle? Very good. To find all the missing sides and missing angles. So I could give you something like measure of angle B is 53 and side A is 12. How do I know this is a side? Lowercase. How do I know that's an angle? Capital letter. Very good. So I label this. Does it, C is my right triangle always. Does it matter where you put A or B? No. Now remember, your side is across from your what? Angle. This is angle B, side B is there. Angle A there, side A is there. Okay, and now start finding this. If I know C and B, how could I find A? Add them up and do what? Subtract from? Very good, and go from there. Are there any questions on your learning targets? How do you feel on the second one? I need a hand signal. Okay. Let's look at our homework. I've already worked it out. I want you to check your work. There's number 1 through 6. Number 1, your theta is 40.6 degrees. Number 2 is 35.0 degrees. Number 3, x is equal to 16.4. Number 4, x is equal to 1.7. Those are just finding angles. 5 and 6, you're solving right triangles. 5, angle A is 67 degrees. Side B is 2.7. C is 7.6. 6 is 73.3 degrees. B is 16.7 degrees. And C is 10.4. Are there any questions on 1 through 6? Take a moment and look at your work. If I need to explain any of those in detail, please let me know. Which one, buddy?
Does it say 35?
35.0. Put second tan, parentheses, 7 divided by 10, close parentheses, and see what you get. Okay? No. I would check your work. Yes. Did y'all get something different? Okay, then I might have just been a little off. 2.73, I'm good with that, okay?
No, we got
Just the plain number 3? Okay, then I might have made a mistake. We'll go with that. Y'all got 3.
I got 16.4.
Okay, hold on now. Hold on. Shh. Oh, we talk about number 5 right here. Okay. It should be close to 3. 3. C, do y'all agree with 7.6? Okay. Number 6. Did y'all get 73.3 for angle A? Angle B 16.7 is side C 10.4. There's 7 to 8. 7 is angle A is 46 degrees. Side B is 8.9 and side C is 12.8. Number 8, angle A is 37.8, angle B is 52.2, and side A is 6.1. Any question on 7 and 8? Now let's look at 9 and 10, the word problems. Want to know the word problems? Number 9. A construction company is installing a 3-foot-high wheelchair ramp. There's your ramp. Onto a landing outside the office. The angle of the ramp must be 34 degrees. What is the length of the ramp? What is slope? I don't write the word slope on that one because you're thinking rise over run. I'm actually talking about the length of that hypotenuse, okay? That is what I mean by that. I will word that better if I put that on the test. So, that first one, you want to know the length. So you're looking for x. That's the height, the length. This is what I'm talking about. I want to know the length of the slope, the length of this hypotenuse. So the first one, x equals 4.4 feet, and the hypotenuse is 5.4 feet. Number 10, it says the London Eye is 135-meter tall observation wheel. So here's my London Eye, it's 135 tall. It's 135 here, it's going to be 135 over here. If the passenger is at the top of the wheel and sights the London Aquarium at a 58-degree angle of depression, remember, if it's angle of depression, you've got an imaginary line going from here through the sky, you're looking down. So it's from that imaginary line to you looking down. So that's why 58 degrees is right there. And you want to know the distance between the aquarium and the London Eye, which is this x right here. Or you could put the x down here. That's fine. But the x right here. And then you did tangent of 58 equals 135 over x. I do it up here because you want the angle, you want to make the triangle up here. And you get 84.4 meters. Yes, honey. That's why you get. That's what I used to do in high school, and I hated these problems. And that's how I figured out how to teach it. Was you just got to remember that when you deal with angle depression, you got to go with the line that's going through this imaginary through the sky right there, and it's going to be between there and looking down because you want to get the different answer if you put it down there. Are there any questions on homework? You feel good about that? I need a hand signal. Mason? Oh, no, I didn't. You didn't leave it up quick. Alright. Are y'all good with what we're doing the rest of the week? Just practicing all this? Okay, here's your note. I was nice. I was going to make a copy of your notes on the board, but I came with you as a copy. Thank you. Welcome. Now, when you get to college, you know your math class is not going to have to copy notes tonight. You take calculus. You have no idea. A world without math. You shouldn't forget how to factor within a year. Factor is a beautiful art. These are textiles, huh? Okay, Jackson, get the lady, clean that up, please. There's paper towels in the bottom. What now, buddy? It's the form that takes in negative b over 2a.
I'm forgetting what B is.
B is the number in front of just an x. A is in front of the variable square. X squared. A, B, C. C is your constant.
It's standard.
Look at that, Jack, if I had this problem right here, buddy. A will be 5. B would be negative 3.
Oh, yeah.
Not coming, I reckon. All right. Guys, we have a lot to do. We've got too much talking right now. Okay. This first part will be on your test. Is a quick review converting from degrees to radians or radians to degrees. Okay, so our first learning target is I can convert between degrees and radians. Okay, so to do that, you either multiply by pi over 180 or 180 over pi. Now, guys, if you're going from degrees to radians, if I'm going from degrees to radians, what's in radians that you know that is? How do you know something's in radians? What's in the numerator? Pi. So if you're going from degrees to radians and you want radians, which one would you multiply by? Pi over 180, because don't you need to have pi in the numerator? That's how I remember it. So on this number 1, I'm going to multiply 60 by pi over 180. Cross simplify. What can I take out of 60 and 180? 60. So that leaves pi over 3. Alright, now number 2, I'm going from radians to degrees. If I'm going from radians to degrees, what has to disappear? That pi's got to go. Pi's got to go. So would I multiply by pi over 180 or 180 over pi? The reason I choose 180 over pi is because the pi's will cancel out with them. So that's how I remember it. Does that make sense? Y'all all good? Thank you. So 180 over pi, these pi's cancel out. 6 goes in 180, 30. Is that 330? Yes. $135. How am I going to convert that to radians? Multiply by what? I think 45 can go on both of them. 45 goes in 135 3 times. And this is 4. So it's 3 pi over 4. Three pi over 4, I multiply by 180 over pi. 4 goes in 180 45 times. That's going to be 135. You did this last year in Algebra 2. It's on the syllabus, so I have to cover it, but it's real easy. Yes, Tyler.
So you wanted us to show our work for the easy ones 60 degrees, we know that's pi over 3.
Alright, now here's our bulk of our lesson today. I can solve oblique triangles by using law of sines or law of cosines. You cover this in geometry. You probably didn't cover this in Algebra 2 last year. Probably just geometry, so this will be a review for examples. Now, this is my favorite one. Love the law of sines. Love the law of sines. Law of cosines require a little bit more work. Now, you got to be able to look at a situation and know which one to use. It's easier for me to remember. If you remember what law of cosines is used for, everything else is law of sines, okay? So law of cosines, you only use law of cosines when you're given side, angle, side. And what does that mean when I say side, angle, side? The angle is in between the two what? Sides. Or side, 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 which is how many sides? That's the only time you use law of cosines. Everything else is law of sines. So if you're not given that situation, you know to go to law of sines. Does that make sense? Okay. Now, law of sines. Let me tell you how law of sines. This formula looks a lot more complicated than what it is. It's just saying that you can set up a proportion. That formula is saying you can set up a proportion with any two over here and 2 over here. Okay? And what I mean by that, when you're doing law of sines, guys, what you want in your first fraction is an angle and the side across from it. That's how you start a law of sines, okay? And then you have one of the ones missing on the other one. So you're just going to have two fractions. You're not going to have 1, 2, 3 fractions, okay? You're going to have 2. But this is saying that you can set it equal, like let's say you had angle A and angle C. You can forget about that and just set those two equal to each other. That's what that formula is trying to tell you, okay? Now, law of cosines, what's great about law of cosines, the only thing I like about law of cosines is you have to start off with this formula one time, one of these formulas, doesn't matter which one. But after you do it one time, you can use the law of sines for the rest of them, okay? So let's look at the first one. Always draw a picture. It says sketch each triangle and then solve, okay? So I'm going to draw a triangle. Remember, it's not right triangle. A is 20, C is 25, and C is 80.4. It says solve the triangle, so you got to list everything you're missing. I'm missing angle B, side B, and side A. Which one could you find easy and quick? Angle. By adding them up and subtracting from what? 180. $20 plus 25 is 45 minus 180. And that's 135. Now I look at this. I have two angles and a side. Do I use law of cosines for that? Do I have side, angle, side there? Do I have side, side, side? No, so I'm using law of sines. So what I do with law of sines is I find the angle and the side across from that I know. You see C right here? And you see you have that across from it. Does that make sense? That's what you start off with. So I'm going to put sine of 25 over 80.4. You want to find, let's find side A first. Oh, A is 20 degrees. 20 degrees. So now I'm going to cross multiply. Now guys, I'm going to do all this work in my calculator. I'm not fixing to write all these decimals down right here because you could do them. So what I'm going to do here, watch how I do this. I'm going to do sine of 20 times 80. First of all, I'm going to check, make sure my calculator's in the right mode. Cosine of 90 should be 0. Yep. Okay. Now I'm going to do sine of 20 times 80.4. And then I'm going to divide it by what? Let's round to the nearest tenth. A equals 65.1. You're intelligent enough, you don't have to show me all those steps. So A equals 65.1. Now B, I need to find B. Well, I'm going to start off with my C part again. Sine of 25 over 80.4 equals sine of, that's 135 now. And I get 134.5. That makes sense because that is the largest angle, and the side across from it should be the largest side, and that is. So that's 134.5. Does this come back to you? Law of sines. Now, so you said, Mr. Trish, you giving us these formulas? No. They are easy to remember. On law of cosines, whatever variable is here, the angle is over here. You put the other two variables, b squared and c squared, always minus 2, and those two variables are multiplied. Does that make sense? So you really don't need that. All right, let's look at number 6. I'm going to draw another triangle. Okay, remember when you draw this, is the angle's going to look like what you mean put down? No. This is not this does not look like a 108-degree angle. I'm just sketching me a picture. Holly, what situation am I giving there, hon? Side angle side. So which one I have to start with on this one? Law of cosines. Law of cosines. Okay, let's list everything I need to find. I need to find side A, angle B, and angle C. And I'm going to start with the little a because aren't the formulas written so that you can find the little sides right there? Like A equals, B equals, C equals. So I'm going to start with the sides like that, okay? Just have a moment. A squared equals, B squared is 15 squared plus 18 squared minus 2 times 15 times 18 times the cosine of 108. Be very careful inputting all this in the calculator, like 15 plus 18 squared minus 2 times 15 times 18 times cosine of 108. Then I'm going to take the square root of that, use my answer button, and I get 26.8.
What did you get?
26.8.
Can I see your calculator? Put the thing back.
It's a calculator. You type in. Let me do this again with you. 15 squared plus 18 squared minus 2 times 15 times 18 times the cosine of 108. Then you got to take the square root of that because it's a squared. So second square root, second answer, 26.8. And guys, the reason that you can use law of sines now is you know your angle A. Do you know the side across from angle A now? So you can set up that proportion. So now I'm going to do sine of 108 over 26.8. Remember, the law of sines, you need to know an angle and a side across from it. That's why I can use law of sines now. Equals sine of B, I'm going to find B, sine of B over side B, which is 15. So 15 times sine of 108 equals 26.8 sine of B. Divide both sides by 26.8 right here. Now, watch how I put this in the calculator. I'm going to put 15 times sine of 108. I'm going to divide that by 26.8. Now, I get this decimal. Am I looking for an angle or side here? So will I hit sine or second sine? So I'm going to hit second sine. I want that answer, so I'm going to hit second answer. And my angle's 32.2. So what I did, guys, is I said 15 times sine of 108. I divided by 26.8, got this big decimal. I'm looking for the angle, so I hit second sine, and I put that decimal down there. Does that make sense? Good. So that's going to be 32.2. So angle B is 32.2 degrees. Now that I know angle B and I know angle A, how can I find angle C? Add them up and subtract it from 180. And I get 39.8 degrees. So guys, you only do all this long stuff, log sines, cosines, if it's not a right triangle. If it's a right triangle, you do what we did last night for homework, the basic sine, cosine, tangent. You see the difference. But if it says it's an oblique triangle, you have to resort to one of these laws. Who's asking y'all's group? All right, let's turn it over to number 7. We might not get to number 8 today. I have to do 8 tomorrow. Okay, angle A, 80 degrees. You can look at that and tell there's an angle and a side across from it. Will you use law of sines or law of cosines? Law of sines. So I'm going to make my little chart of my missing things. Angle B, angle C, and we're looking for side C. So now I'm going to go sine of 80 over 6.5. I'm going to find B first, sine of B over 3.4. What's your question, buddy?
Would it matter how you set up the triangle?
No, as long as you got stuff labeled. Like if your A was up here, you need to have 80 there. The side A has to be crossed from wherever your angle A's at. Side B has to be crossed from wherever your angle B's at. Now I'm going to divide both sides by 6.5. So I'm going to type in the calculator 3.4 times sine of 80 divided by 6.5. Remember, I'm looking for an angle, so I'm going to hit second sine, second answer, and I get B is 31.0. It's very important to put the point 0. If you just put 31, I think it came out to a whole number. Now that I know angle A and angle B, I can find angle C by adding them up and subtracting from 180. Angle C will be 69 degrees. It came out to straight up 69, so you just put 69. Now I need to find side C, so I'm going to do sine. I'm going to use the same one I used over here. We've got to find side C, so sine of 69, cross multiply. I think it's 6.2. We're going to stop there for the day. But hold on, we're not going to be putting everything up in our book bags yet. Are there any questions so far on all sines, cosines? We're going to finish that number tomorrow. Is a side, side, side. Now let's look at your assignment. It looks like a lot, but it's odd, and it's like less than 10. Page 478 in your book deals with converting between radians and degrees at first, 5 to 11 odd, 17 to 19. Take you a grand total of 5 minutes. Page 514 is 11 through 17 odd. Page 521 is 15 through 19 odd. On page 521, if there's any side, 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 you can leave that off since we ain't got it that yet, okay? But if you run into that, we'll work those tomorrow in class. Everybody good with that? What now?